All right, you guys, this is Allegations Lecture Video 2. I want to pick back up where I got cut off from Lecture Video 1. But as I was saying that, I want you guys to just keep in mind that allegation problems will provide you 3 concentrations, all right? Allegation problems are going to provide you 3 concentrations, but keep in mind that regardless of how the concentrations come, whether it's a percentage or fraction, or a ratio, and it may even come in words like water. Water is 0%, all right? Base cream is 0%, all right? Regardless of how it comes in allegations, we always work with percentages, all right? We're basically dealing with those whole numbers. All right, so let's just keep it moving and let's go ahead and let's just go over the process of solving allegations. So if you turn to page 539, all right, at the page 539 talks about calculating medication dilutions using allegations. Remember, I said dilutions and allegations are very similar, all right? The definition is that you're taking 2 stock concentrations. In dilutions, you're only taking 1 stock concentration and lowering the strength. Now in allegations, you're taking 2 stock concentrations and combining them together to lower to a strength that falls in between those 2 stock concentrations. All right. So when it comes to allegations, in order to solve an allegation, you must first always use an allegation grid. All right, so your allegation grid is basically a tic-tac-toe grid, all right? This is how you always begin solving an allegation problem. So once you identify your 2 stock concentrations and your quote-unquote desired concentration, then you are able to take those 3 concentrations, and they must be in percentages, and place them within the allegation grid. So, first things first, on the top left-hand corner of your allegation grid is where your highest percentage goes. All right? Your lowest stock percentage goes at the bottom left-hand corner. And your desired percentage goes in the middle. All right. All right, your desired percentage goes in the middle. So let me put some numbers to what it is that I'm telling you. So let's just say that the 2 stock percentages, you have a 10%. So you're going to put the 10 here. Your lowest percent, let's just say, is 2. And let's just say that your desired percentage is 5. All right. So again, your highest percentage goes in the top left-hand corner. Your lowest stock percentage goes in the lower left-hand corner, and your desired percentage goes in the middle of your allegation grid. Now, before you move on and do anything else, you ask yourself, does the desired percentage fall in between 10 and 2? Well, it does. You can count from 2 to 10, and 5 falls in between. You're going to come across 5. 2, 3, 4, 5. If I keep going, 6, 7, 8, 9, 10. 5 falls in between 2 and 10. So now that you know that your percentages are placed within your grid correctly, then your next step is to subtract diagonally. So I'm going to move back up here. So in order to get your parts needed, on the right hand side of your grid is considered your parts needed. So in the top left hand corner, technically will be the parts needed for your highest. But in order to get that number, you have to subtract your lowest from your desired to get the parts needed for the highest percentage. So even though I subtract diagonally lowest from desire, you read it from left to right. So although I'm subtracting lowest from desire, that's going to give you the parts needed for your highest. All right. Same thing here. In order to get your parts needed for your lowest, you have to subtract your desired from your highest, or your highest from your desired, to get the parts needed for the lowest percentage. So let's go ahead and look at the grid with our numbers here. So in order to get the parts needed for my 2%, I have to subtract 10 minus 5. So if I subtract 10 minus 5, that gives me what? 5. That is the parts needed. I need 5 parts of the 2%, because even though I subtract diagonally, I still read it from left to right. All right. So I now need to subtract 2 from 5. So 2 minus 5 gives us, yes, it gives you a -3, but we always work in absolute value. So your answer is 3 parts. So you need 3 parts of the 10%. Again, you subtract diagonally, but you read it from what? Left to right. So 2 minus 5 gives me 3 parts needed for the 10%. All right. So I want you guys to go ahead, and I'm going to use another document here. I want you guys to turn to example 13-9. So example 13-9, which is on page 540. Let's go ahead and let's read the problem, and we're going to try to solve this. So it says that we are to prepare 1 liter solution of a 70% alcohol from 50% and 95%. All right. So my first question to you is, what type of problem is it? What type of problem do we think this is? Well, since we have 3 concentrations, which are all expressed as percentages, then we are dealing with, then we have a what? An alligation problem. All right. So this is an alligation problem because we're dealing with 3 percentages. I have a 70%, I have a 50%, and I have a 95%. So now that we know it's an alligation problem, your next step is to draw your alligation grid. So I'm going to draw my alligation grid here, which is basically a tic-tac-toe. So my alligation grid, on the top left-hand corner goes my highest stock percentage. Whatever I'm preparing is my desire. So I am preparing, so I'm going to put right here on the side, I am preparing, that's RX, 1 liter, and it tells me of 70%. This is what the doctor is asking for. What I have in stock, because I'm preparing that 1 liter of 70% from a 50% and a 90%. So now that I know this information, I pulled out my information. My highest stock percentage, which is 90, goes in the top left-hand corner. My lowest stock percentage goes in the lower left-hand corner. And my desired percentage goes in the middle. So before I move on, you are to ask yourself, does 70% fall in between 50 and 90? It does, because if I count from 50 to 90, I'm going to come across 70. So now that I know that 70 falls in between, you can now subtract diagonally. So if I subtract 90 from 70, you get 20 parts needed for the 50%. You remember, you're subtracting diagonally, but you're reading it from left to right. Now I'm going to subtract 50 from 70. 50 from 70 gives me what? 20 parts. Even though it's a negative, we always work with what? Absolute values. So that means there's 20 parts needed for the 90%. All right. So I'm not finished with this problem, because the parts needed just tells me the parts of the 50 and 90%. That doesn't tell me in detail the weight or the volume for that 90%. It just says 20 parts of 90%. That could be 10 milliliters, 100 milliliters, you don't know, but you can solve that. So the next step that you guys need to take is you look at the quantity given. The quantity given in this problem is the 1 liter. All right. The quantity given is that 1 liter, which we work in milliliters, so that's 1,000 milliliters. That 1,000 milliliters goes to the desired percentage. So whenever your given quantity goes to your desired percentage, you have to solve the problem and get the volume for both stock percentages. All right. So your next step is that you have to get your total parts. So I am going to determine my total parts, which is 40 total parts, because 20 plus 20 is 40. So I need 40 total parts. All right. And now I'm going to be able to solve for both. So for 90%, all right, you're going to take the parts needed for 90, which is 20, over your total parts, and you're going to multiply that by the given quantity of 1,000 milliliters. All right. So technically you need 500 milliliters of the 90%. You're going to do the same thing for the 50%. So for the 50%, you're going to take parts needed, which is 20 parts, over your total parts, which is 40, multiplied by the given quantity of 1,000 milliliters, and you're going to get 500 milliliters. So that means you need 500 milliliters of the 90% and 500 milliliters of the 50% in order to prepare 1 liter of 70%. Well, that makes sense, because if you add these two volumes together, the 500 milliliters and the other 500 milliliters, you get what? 1,000 milliliters. All right. I'm going to stop right there, and I'll pick back up in the next lecture video.